need to reload my presentation. No, not correct. So. So. Okay. Can you see the presentation now?
No.
No.
Okay. Yeah, okay. Okay, something wrong. I don't know what happened, but I can see my presentation, but no. But yeah, I have some problems here. I don't know what's going on. What? And so, what's now? Can you see that?
Yeah.
Yes.
Ah, okay. Okay, thanks very much for help. Yeah, so let's continue with some, yeah, next page. Okay, so I stopped here at intelligent manufacturing. So there are also some yeah, interesting words and technologies that gives an impression how it works now in the when we speak about intelligent manufacturing. So I think you all know what a 3D printer is. Normally, it's the problem that exists that you cannot use all materials for that. As far as I know, the company Hyundai in South Korea, they had success in building an engine for a car with a 3D printer. Yeah. Normally, you need a block out of metal or out of aluminium, yeah, and then you make all the cores and you prepare it for use. And the biggest problem normally is that there's normally oil in the engine, and there's also a water. Yeah, so it's a water-cooled engine, and you need to what's the name? You need to drill holes, yeah, that the oil and also the water can make its way through the engine. And so if you have finished making these holes, you need to shut them, yeah. And this is a problem for a car because for an engine, because after several years it can happen that this that the how to say that that the cap that is closing this holes can become oh yeah can become untight, yeah, or leaky. Yeah, leaky. That's what the word I was searching for. It can become leaky. And with a 3D printer, you need not to drill holes, yeah, because you make all how it should be, yeah. It's making step by step, so it's starting with yeah, with the side on the floor, and it's going up, yeah, until it is finished, yeah. It's taking hours or perhaps days, yeah. So I heard also in China, yeah. So there's a company that is building parts of houses, and so there are many possibilities to use printers, yeah. Or if you have an old timer, yeah, an old car, then it could be that you are not able to buy this part, the spare part for that, so it can be printed. Yeah, so there are many possibilities, but the problem is that the material that you use, yeah, it will take the time to present materials that are as uh, uh, um, as I don't know. Just a moment. Yeah, as stable as it is with a block of that materials, with metal or with alloy or whatever. Yeah. But you can make many things with 3D printer. For if you want to produce only a small series of something, yeah. So therefore, I would say a 3D printer is can be used, yeah. So it's okay for that. If you have a big production, yeah, that for that a 3D printer is too slow, yeah. Yeah, CPS. CPS is a programming style. Yeah. Normally there are two of that. Yeah. So the first one is means the continuation passing style. Normally, what we know is a direct style. So you put in your data, and then you will get back a result. Yeah, that's the direct style. But a continuation passing style has yeah, it has results, but these results are the base for another function, and so it's like how do you say that? It's like a workflow, yeah. So you have a result, and then you have another result, and then you have another function, and then there are some steps, yeah, to do. And this style of this programming has the name continuation passing style. Yeah, it's a programming style, and yeah, so it's what you can do is to make more complex operations if you use such a possibility. Yeah. So the direct style, that's simple. Yeah, because you give in your data and you come back your result directly. Yeah, there's one formula inside, and it's making the result. Yeah, and this is the base for more complex routines. Yeah. RFID. It's called radio frequency identification. So here we have the possibility to use electromagnetic fields, and it makes it easy to track objects. It's causing some problems because the distance normally is very low where you can track objects. So the RFID, so there's you need a reader, yeah, and you also need a sender, yeah, but this sender is passive. So the reader is using radio waves, yeah, and if you have a chip on the other side, an RFID chip on the other side, it gives the feedback. Yeah, so the RFID chip is passive. Yeah, but you only can use it for low ranges, and it's making sense if you need to have security codes. Yeah, let's have an example. If you go into a hotel, yeah, you make the check-in, you can get a card there. Yeah, there are two possibilities. There can be a magnetic stripe on that. Yeah, and the other possibilities are RFID. Yeah, and you put it into the slot of the door. Yeah, and then it opens. Yeah, and it makes it more easy. Another way to use it is in a store. Yeah, you can put a chip on every item, on every clothes, yeah, whatever you sell. And if somebody is going out of the store, it can be checked if this person has paid or not. Yeah. So what you can do is to you can uh, uh, you can check it if somebody is using pathway, yes, or something like uh, like a gate. Yeah, it's a special gate, and then you can check that. Yeah, this is RFID. It's also used by the Amazon Go project. Yeah, but the problem is this RFID chip costs money. Yeah, it's not expensive, but if you use something like that, you need to add it to the price. Yeah, and I know a company here in Germany. It's called Metro. Yeah, and Metro tried to use RFID in stores and in the um, or in the storage, yeah, for example. So the idea was to use an RFID reader, yeah, and you go through your through your warehouse or your storage, yeah, and automatically you will get a feedback how many pieces you have in stock, yeah. But the problem was it didn't work, yeah. It didn't work perfectly, yeah. You need to add this RFID chip to every part. That costs money, yeah, and the second is that the distance can be too big, yeah, and also it depends on the material that these parts have. It can possibly stop stop the radio waves going through the product. Yeah, so if it's something made of metal or also alloy, yeah, it can stop the radio waves. Yeah, and then you cannot track the object that you want. And this is the problem. But for security systems and other possibilities, it works fine. Yeah. Yeah, or you can use it for your pets. Yeah, if it's an identification chip, it's also possible. Or if you have seen the last James Bond film, yeah, or one of the last James Bond films, his boss put him in a chip, yeah, and was more professional. Yeah, had a tracking system for all over the world. Yeah, yeah, so this is then more perfect. Yeah? And, in a film, these chips they don't need any battery or something like that. Yeah, so they're very small. Yeah, that's RFID, and so it's also a possibility that helps logistics, security systems, yeah, pharmaceuticals, yeah. So it's also a possibility for pharmaceuticals. It's more easy because you don't because it depends on the material you need or you have in your stock. Yeah, pharmaceuticals, yeah, that works for that. Yeah, so it depends on the products where you can need RFID or not. Yeah. Yeah, and the next is M2M. It's the name. It's machine to machine. So the idea here is also it can be a business model. So let's the word behind that is telemetry data. Yeah. So you can what you can do is you can use sensors, and these sensors give the results to a computer and gives you the possibility to check how the machine works. It's a communication tool that has to use sensors such as temperature, yeah, or yeah, it can only blood pressure. Yeah. So if you have your Apple Watch, yeah, you have a sensor that's under the watch, and that is tracking your pulse and blood pressure, and then you can see with a GPS where you needed more power, yeah, to run or something like that, yeah. Yeah, so machine to machine refers to direct communication between devices using any communication level, including wired and wireless machine to machine communication. And it's also offering business models. So what you can do here is you can, it's a business model that you find in the airplane industry. You sell airplanes without without the engines. Yeah. So yeah, so all possibilities of engines. So you normally see it when you have airplanes with jet engines. Yeah. And so the idea here is that you offer the airplane to a company, and this company is only buying the airplane, but without the engines. And you pay only for the engines if a service is necessary or needed. So it's another possibility to sell airplanes. Yeah, it makes it easier for the companies to buy an airplane, and but these companies only pay for their when a jet engine is used. Yeah, so you get all data. So it's normally working like that. That an airplane has a connection to a satellite, and every hour these data from the engine are sent to this to the satellite, and then it will be sent, for example, to Rolls-Royce, yeah, in England, where these jet engines are built. So, and if you have data that are out of a range, then you can say, okay, it's necessary to have a service, and you need where you have to look, yeah, because you have the sensors, yeah. We also have sensors in cars, but the sensors we have don't have this accuracy. Then you find it in an airplane. I think you remember the flight Malaysian Airlines 370. Yeah, so it was on its way from Malaysia to China, and just a few years ago, 5-6 years ago, I think. And as the pilot, he has been in contact with Chinese tower, And so he said, okay, we are on the way. And so we switch off the contact and we say goodbye to Malaysia. Yeah. So, and this was the moment where the tracking a flight tracking system has been switched off. Yeah, and the airplane made a turn, made its way over Malaysia again, and then made its way in direction to Australia. And then there, on its way, after a few hours, it was lost. Yeah. The problem was that this tracking system that is very exact has been switched off. So nobody knew where this airplane was. And the idea then came up to use this machine-to-machine data because every hour the information will be sent to the satellite. So, and then the specialists, they took the time and the way to the satellite, yeah, from this data, and found out that the plane has made a turn and had made its way to Australia. So it was, as far as I know, this plane was flying 6 or 7 hours after that, after the switching off of this tracking system. And then it got lost after 7 hours. Yeah. So the specialists, they had 7 information, yeah, from the tracking of this satellite system, and so they found out how the way was, and yeah, but you know that this airplane has not been found yet, yeah, after years. Only a few wreck parts have been found on islands a few thousand kilometers ago. So this airplane is lost, and nobody knows what the situation was. Yeah? It is possible that the pilot wanted to make a suicide, and he took all the passengers with him. Yeah, so that's yeah, I think the most realistic idea, yeah, of that. Yeah, that's machine to machine. So you can use it for airplanes. You can use it for the cars. Yeah, to gives back any working situation. Then your health data. Yeah, we also talk here about telemetry data that gives you information about your health and about your condition, and so as far as I know, the health insurances are very interested to get your health data, and but here in Germany it's not possible to do that because we have a social system, and you can't data to insurance, yeah. Because it is said, okay, oh, this person is in a very good condition, and so let him pay less, yeah. And the other person, oh, this person is very is ill, yeah. so let him pay more, yeah, and or we will quit his assurance, yeah? Because he will become too expensive person. So here in Germany, it's there's no possibility to do that, yeah. Yeah, but what you can do is you can use it for analysis, yeah, and whatever, yeah. More recent machine-to-machine communication has changed into a system of networks that transmit data to personal appliances. The expansion of IP networks around the world has made machine-to-machine communication quicker and easier while using less power. These networks also allow new business opportunities for consumers and suppliers. Yeah? So that's the way. Automation, that's logical. So if you are selling goods in an automat, yeah, or in a vending machine, yeah, or different words for that, then you will then be informed, okay, you have put new products in this machine, and yeah, so it's it's a possibility to check when it's empty. Yeah, it's also very simple. So we speak about remote monitoring also. Yeah. Yeah. So this is a possibility with machine to machine. So you see, yeah. So if you see these technologies, these are all possibilities to generate new business plans or business models. Yeah, you can sell this this kind of information, yeah, or you can use it to offer a special service. Yeah? It's uh, yeah, new possibilities able before, and it's possible also with the internet. The problem here, this kind of technologies, yeah, they can be dangerous, yeah, for the companies, for countries, because they can be influenced. Yeah, so we speak about uh, uh, internet wars. Yeah, so you try to manipulate the production of something, yeah, or some products or energy, whatever. Yeah, you can initiate possibly an explosion. Yes, and this can cause problems if a system like that is not secure. Yeah. And this is also the reason that Russia is taking currently all servers from all over the world and bring them to Russia. Yeah. In China, it's, I think it's nearly the same. Yeah, and the, so these countries try to minimize the risks from outside. Yeah. I think you also know the problems with the US, yeah, with Huawei. Yeah, it's the same problem with 5G. Yeah, and the Americans are afraid that this data can be used for an attack or to influence somebody. And yeah, so I think this is the end of the free internet use. Yeah, so in future it will be more complicated to use a system like that. Okay, before coming to the next page, we have only 1 minute 55, 54. So let's make our break here. So we have now 1:29. So let's continue at 1:35. Yeah, so it's a 6 minutes break, and then we will continue our course. Yeah. Okay. See you then.